Greetings, this is Phi. Yesterday I ran another test of our polynumbers project. Kept the same number of curves, 200 curves, but this time increased the resolution to 1 over 2 to the 16th, or 65,563. So we're starting to see smoother curves. I just want to mention that I'm still using the SymPy polynomial evaluation for determining our values for plotting the curves. Federico has demonstrated a really unique way, or actually rather simple way of deriving those values, and I'm going to return to that, and we'll kind of compare the two and maybe even do some speed tests on that. His seems to be blazingly fast, but I'm kind of staying inside the SymPy world because we're going to be extracting other information around that. So here we go. You're seeing on the screen here the matplotlib interface for the 200 curves, and I am planning right now an animation. So I want to explore this, controlling the aspect of the screen very incrementally, so we can slowly zoom and pan around inside of this amazing structure that we're looking at here. So there are two different ways that I want to do that, and one is to kind of like stretch this, starting from one end and stretching it out, and then panning over to the other, and then maybe collapsing it back. So I want to kind of demonstrate, how that would work here. So just going to use our zoom tool. I'm holding the X key down and stretching from just outside the figure, and I'm going to go to the halfway point. So each time I'm going to go to the halfway point, and you can see that there's almost no change. We see there's a bit more patterning showing up. Well, let's just do it again. Let's just go halfway and see what happens, and we're just going to keep going halfway each time. So that was 3, right? I think. So 4, 5, 6, 7, 8, 9, 10. Kind of exciting, isn't it? So you can already see our curves are much smoother here, and the last curves, which are very steep as they're entering the figure, we're seeing that they are losing a bit of resolution there, but I think that's easily fixable. Just requires computation time, so we'll definitely be exploring that here in the future. But what's happening here is really, what you're seeing on the screen is really the demonstration of what's happening inside of this figure. And we just have all of these different curves that are overlaying on top of one another, but we can get to see it really kind of fundamentally, and we are really zoomed in here. So I'm going to go one more time, actually, right to the halfway point about. All right, and so we're really stretching this out now. So each of these curves enter through the same point, 0, 0, and they're all just laid out very nicely there for us. In fact, I'm going to even zoom in on that a bit more here. It's quite interesting to look at just this area. All right. And here now we are getting one of the questions answered that I had, like, how many colors are, and I made an error in what I stated the last time. There are 10 colors in this color cycler, and they're quite evident here, as you can see. If you follow maybe one of the more dominant colors like the pink or the yellow or something, and you can see we're on a cycle of 10 with these. And so all of those gatherings that are happening are, some, round robin pattern that's happening with 10 colors. I really can't wait now to start putting some other color maps involved in this. Before we get done today, I'll share a little bit more about that. But, this is really zoomed in, and you can see I'm just going to go back a little bit, actually. Go back to the last one. So we can see as we're doubling over for the first time, we're getting each node has 2 lines that are crossing, and then we have up to 3 lines that are crossing over here, and up to 4 lines that are crossing over here. So each time this wave is moving through, it's coming back and crossing over these other nodes. It's just really amazing. I don't even know how to really speak about it yet, and hopefully we'll get better at talking about all of this. But my idea for the next animation that I want to create is to just slowly stretch this thing out, keeping the 0, 0 in the corner, and just pull this fabric apart. And maybe we can even do it at 60 frames per second and get this really smooth kind of unfolding, unraveling of this. Actually, it's not an unraveling. It's just a stretching. It's a spreading of the spread polynomials. And then once we spread it out, I'm just going to pan. So I'll just go back and pan here, hit P for that, and just begin to move across. And you can see how the patterns are getting more and more complicated as we're going across. We're seeing more lines that are coming together in various crossings. We're starting to see, gatherings of different colors that are happening at different points, and definitely think there's going to be so much more to uncover here in the patterns. So I just plan on making a video that moves across this, and then do the same thing from the end. It's really pretty fantastic at the end too. So let's come in and just go in tight around here. All right, and again, I'm going to stretch from the right-hand side this time, and maybe just jump in about there to get started. Did it go? Yep. I'm not sure. Oh, I think I toggled it off. It wasn't moving. I'm sorry about that. Okay, coming back again. Should start to stretch now. There we go. There we go. Sorry for that. I'm hoping to start making some more formal videos soon that are a bit more orchestrated, but I just can't help but share what I'm seeing here. And you can see this positive negative kind of thing that's happening as we are reaching this far side of our plot, and the field is really amazing, isn't it? Oh, look at the complexity and the interweavings. And we keep stretching it out. Now we're starting to see something that was similar to what we saw on the other side. But remember, half the curves are exiting on the bottom and half are exiting on the top. And it turns out that whatever colorings there are for each of these curves, it's got this kind of red-blue shift that's happening. But anyway, there's so much more to look at in all of this. But I wanted to create a quick video here today, and just this way of almost storyboarding what I'm intending on doing for an animation, and it should be just really dazzling. And of course we can zoom in on other areas too. I think what could be interesting is to stretch it from one of the center points, so come into say an area like this one, and start here, and maybe start to stretch things out in different ways. And you look at this, each of these dazzling patterns in its own light. So that's it for today. There's a lot more happening. So working with Federico right now on developing functions for determining the intersections between curves. He feels pretty confident that we can get get lots of those points, actually calculate them algebraically. He has also demonstrated to me how we can draw the ghost curves and their simple inversions and reflections of the curves that we were already seeing. I mean, I was kind of had that hunch, but he actually demonstrated it. And so in a future video, hopefully we'll start articulating that. So much to share. Thanks again for everyone who's participating. Join us on GitHub, the Geometor project organization, and go to the Polynumbers project. And there we're having discussions in the discussion group there. So right now it's just Federico and I, but you can come in and join us. Please do. And you don't have to be a programmer. You don't have to be a mathematician. If you just find this really interesting and you have ideas about ways that we can, articulate this, happy to hear it. And let's see, I'm going to go here. I just wanted to show you in Matplotlib. So there are a number of basic color maps, and some of the important ones are these perceptually uniform sequential color maps. So with these, if you were to, they have a light and darkness to them, but they also have a color gradient. But if you were to take whatever color gradient this is and convert it to black and white, it would still have the same intensity, right? So these are kind of interesting to use in different ways, and then we just have gradients from white to a particular color, gradients across colors in some cases, which can be quite useful, diverging maps. And I think for us, what we're going to probably be doing is building sets of colors that map to certain things, and that means that we're breaking up a color table to a particular number of color values that we want to cycle through, and whether that's powers of 2 or it's some other kind of pattern that we think can be revealing to us. And of course, we can animate these color maps too. So once we have a figure and we know how to plot it, we can just replot it with a different set of colors. So we can actually move waves of color through this field, and that can help us to understand some of the interactivities that are happening there too. So there's definitely a lot to look at here. One of my favorites is copper, and I'm missing it here right now, copper. And I've used that with some of my phyllotaxis patterns, and it has just a beautiful gradient with a little color. It's almost like a sepia kind of thing. Looks very metallic and stuff. And so, I think there's art to be made, here as well as investigation. And of course, I think if we create something dazzling, it will help to create a sense of wonder in folks. That's really all that we can ask for. So again, thank you everyone who's participating. Thank you, Dr. Wildberger, and we're going to continue developing, and we'll keep you up to date. Thank you.